In this demo, I'll be showing you how you can use the new application fingerprinting feature within Kasten K10 to ensure that Kanister Blueprints are automatically applied to your workloads. Kasten K10 provides deep integration with Kanister Blueprints, allowing us to quiesce workloads before performing storage snapshots of PVCs, and even allowing you to orchestrate logical backups as part of your K10 policies. In this environment, we can see I already have a number of blueprints installed on my K10 cluster, including this MongoDB blueprint that's used to sync and lock the database before a snapshot operation, and then immediately unlock the database once the storage snapshot has been created. Typically, you would configure a blueprint for a workload by either adding a Kubernetes annotation to it or by assigning through the K10 dashboard, as we're doing here. Note the canister icon indicating the blueprint has been assigned to this deployment. If we look at our two additional applications, we can see from the metadata automatically discovered by K10 that each one is also using its own MongoDB deployment installed via the Bitnami Helm chart, but the lack of icon tells us that it hasn't been annotated with our Mongo hooks blueprint. While blueprints provide great power, every Spider-Man fan knows that with great power comes great responsibility. In this case, the responsibility of ensuring all your workloads are annotated with the right blueprints. But that's where app fingerprinting is going to make our lives much easier. This new Kasten custom resource, Blueprint Bindings, will allow us to define what you can think of as a policy for assigning blueprints. We associate which blueprint we want to assign, Mongo hooks, with a highly customizable set of rules, what we call the application fingerprint. Here we see in order for K10 to automatically apply the blueprint to a workload, we need to match all of the following conditions. First, this binding will only apply to deployment workloads, as stateful sets would require a slight variation on our blueprint. Next, we'll ignore workloads where we have already manually annotated a blueprint. This would allow us to override the blueprint binding if necessary. And finally, those deployments need to have Kubernetes labels indicating that they're MongoDB workloads that were deployed via Helm. We'll jump over to our terminal and get this blueprint binding installed on the cluster. And now we can go back to our K10 dashboard and run the backup policies for all three applications. As our backup is running, I can already see our blueprint binding as well as our blueprint in the list of artifacts associated with my application, indicating that the blueprint has been applied. And now that our backups have completed, let's search the logs for each of our three applications for the fsync commands run by our blueprint to quiesce the database. For each application, we see fsync lock being applied, followed by fsync unlock seconds later, again, once that storage snapshot has been created. As new applications are added to the cluster and 3 quickly becomes 30, hopefully you can see how app fingerprinting can help you scale your operations and ensure you can restore your critical data with confidence. To dive deeper on configuring blueprint bindings, check out docs.kasten.io.